So which two gases will diffuse at the same rate at the same temperature?
Carbon monoxide and nitrogen.
Yeah, that's fine. A student measures why, because why do they diffuse at the same rate? I mean, they do diffuse at the same rate, but why?
To be honest, I guess I don't know.
And so what does the speed of diffusion depend on? It depends on the mass of the particles. Heavier particles, they travel slowly. Lighter particles, they travel very quickly, right? So they're going to have, I mean, these two particles have the same mass because carbon is 12, oxygen is 16. So what's the mass? It's 28. And nitrogen is 14 plus 14. So that's 28 as well. Is that clear? So they have the same mass, so
Okay.
they're going to diffuse at the same rate. So it's B. What about the next one? A student measures the time taken. She's measuring the time for 2 grams of magnesium to dissolve in 50 cm cube of sulfuric acid. So which apparatus do you think he needs to do all of that? Will he need a
Okay, so there should be a stop clock involved, and then okay, cm cube measuring cylinder
okay?
and balance because grams.
Yeah,
Yeah.
you don't need temperature. They're not measuring the temperature, so it's
Yeah, there's no.
124.
It's A.
As the next one, what measurements are used to find the RF value of T? This is this is T. So how would you?
Okay. So distance from the baseline and then distance of the solvent front with the baseline. So 3 and 4.
Yeah, and it's basically 4 divided by 3, right?
Yeah.
So X and Y are two elements, two different elements. X and Y have the same number of nucleons. So when they're two different elements, proton, neutrons, and electrons, which thing is different if they're different elements?
The electrons.
Not specifically the electrons, it's the protons.
Okay. So it's isotope
No,
or
this
no?
is not an isotope. Isotopes are that they're the same element, but they have different nucleons.
Oh,
Or
and they're two different elements. Okay.
Because remember, an element is going to have the same number of protons, which is normally equal to the number of electrons, but electrons can be lost and gained. So they can form ions. So, but the proton number doesn't change. And obviously, as anyway, so they're two different elements, so they're going to have different number of protons, but they have got the same number of neutrons. So they're not isotopes. Is that clear? They're not isotopes.
Yeah.
Yeah, it
It
says two
has
different
the
elements.
same. It has to be there in the wait. Uh, can it be there in they're in different groups of the periodic table? Because it says they have the same number of nucleons.
Let's start with they have the same physical. They're not going to have the same physical properties because they're two different elements. Yours, Marwa, looks to be fine, but let's go with their atoms have the same number of electrons. Well, if they're two different elements, they're going to have different protons and different electrons, right?
Yeah.
They're in different groups of the periodic table, so it is possible they can be in different groups, but even in the same group, you can have different elements, right? So that's
Yeah.
we're not 100% sure about that, right?
But the next one doesn't make sense with it. They have different relative masses.
They're going to have the same relative masses because the nucleons
Are the same.
so they are in different groups of the periodic table. So I mean, they're different elements, but you can have different elements in the same group. they have different relative masses. Which is not true as well. I mean, this is definitely incorrect. Because if I open the periodic table, same elements can have, like if you look at argon and you look at calcium, right? Both of them have the same exact nucleon number and the mass, although they're different elements. This one has 20 protons and electrons, this one has 18 protons and electrons. So they said that they had the same number of nucleons, so which is why they can have the same masses as well. So I guess it's definitely C then, that they're going to be in in different groups. But let me double check this one. So this one is 4, right? 4 is C. The same number of nucleons. So I think he wanted us to refer to the periodic table because the elements that have the same number of nucleons, that it's just this one. It's argon and calcium. So I think you have to look up in the periodic table and then answer, because these are the only two elements that have the same number of nucleons, even though they're different elements. Is that clear?
This is clear.
Because if you look at the rest, they all have. So if you look at the rest, they all have different neutron numbers. All of them have different neutron numbers, except for calcium and argon. So next one, diagram shows you've got 3 structures. Which one is diamond? Which one is graphite?
Graphite is. Wait, diamond is. Graphite is R. Graphite is R.
Okay.
And diamond is Q.
Diamond is Q, so that makes it C.
Yeah, and
C.
P is silicon oxide.
Silicon oxide, because there's one silicon atom, so now we have 4 oxygen atoms. The oxygen atom is then bonded to silicon and so on. You got the dot and cross diagram of a molecule of HCl, right? So which one? How many bonds would group 7 make, by the way?
1.
1. So HCl is just H makes 1 bond as well, right?
Yeah, and hydrogen only has 1 atom to bond with.
Yeah, and Cl is a
A.
group 7, so it's got 6 other electrons, right?
Yeah, so it's A.
So it's A. The reaction is given, and which one shows the state symbols? So do you know what the solubility is? Is barium chloride soluble or insoluble?
It
I mean,
it is soluble.
chlorides are all soluble except for silver and lead.
Yeah.
So it's soluble, right? So it's aqueous, right? Sulfuric acid is obviously aqueous, right? All acids are soluble, right? So that's why it's A. I mean, the first two. Sulfates are all soluble.
Solid.
Except for sulfates are all soluble except for 3, 4, which are
barium
and lead and calcium and calcium partially and strontium.
Yeah.
So that's a solid. And HCl is aqueous as well, right? So it's A.
Yeah.
As you've got this moles question, it says 0.5 moles of methane react with 0.5 moles of steam. So 0.5 reacts with. So can you are they reacting in the right ratio?
Yeah. Yes.
It's 1:1, right? So 0.5 will react with 0.5. So how much carbon monoxide will be produced?
0.5, and then it should be 1.5.
So what is the volume?
A. No.
No, volume of gas.
Whoops.
So 0.5, well, how many dm cube is that? And how many dm cube is that?
We need to multiply it by 24.
24, right?
Yeah, the volume of H2 is 36, and the other one. So it's D. is 12.
So indeed, you can remember volume of gas is, what's the formula of volume of gas? It's moles multiplied by 24, right? And the compound of element X has the formula X2
Yes.
and a relative formula mass of 144. So it's X2O, and he says that its MR is 144. So what do you think is the mass of X? I mean, you don't know what X is, right? So you're gonna take it as X. There are two of
Yeah.
them. Oxygen, you know that's 16, right?
Yeah.
You take it to the other side, so this will be what? What's 140, 128?
Yes, 128.
And then X divided by 2, that's gonna be 64. So
Copper.
that's copper, right? As the next one, you got electrolysis. He says that at which electrode is hydrogen gas produced? Now, concentrated HCl, right? Now, tell me first thing, what are the ions present at cathode? If it's HCl. There's going to be H plus 1 ions and Cl minus 1. H plus 1 go to the negative side and Cl minus 1 go to the. And since concentrated means it's aqueous, so that means there's water as well. So from water, there are going to be two ions, H plus 1 and OH minus 1. On the other
Yeah.
hand, you got NaCl. So it's Na plus 1 at the negative side.
Positive and Cl is with OH negative.
And since it's again aqueous, I said,
So
tell
we're
me,
gonna see which one is more reactive, hydrogen or this. And I mean, least reactive. Hydrogen is less reactive than Na, so we're gonna be
yeah.
hydrogen.
So it's going to be, it's diatomic. So the H plus 1 is the one that's going to gain electrons.
Yeah.
And on the other side, the only option you got is H plus 1. So that will by default be H plus 1.
Yeah.
So at which electrode is hydrogen? Electrode 2 and 4, right?
Yeah.
And whenever it's concentrated on the other side, it's going to be Cl minus 1 that loses electrons, right?
Yeah.
Whenever it's concentrated, it's always Cl minus 1. That's the next one. The diagram shows the electrons of copper sulfate using inert electrodes, which row shows the movement of electrons in the circuit. So this is the cathode,
Yeah.
which is the negative, and that's your anode, which is the positive. So
It's
where do
B, it's like towards
yeah, that's the direction of the electrons. And on the other side, this is the direction of electrons, right? So it is B. And so which row shows the chemical change and the physical change?
over here the chemical change is, we can say it can be burning ethanol,
Burning ethanol, yeah, that's
and then rating ethanol is the physical change.
that's change of state. Next one, which statement explains by increasing the concentration of a reaction? If you increase the concentration, why does the rate increase?
Because it will increase, it will speed up the reaction more.
But why?
There's more to react with.
So which it increases the collision rate of particles. Is that true?
Yeah, that's true. And then also it lowers the activation energy. No, that's wrong.
That only
No.
happens. That only happens with a catalyst.
The next one is wrong too, because it also has activation energy in it. And
Yeah, but
then
that's
it's 1 and 4, so that is B.
Okay, that's true. More concentration, and I think 3 is also true.
No, because Mr. Fahad, number 3 says
I think this
a
is
great.
sorry, it's not true.
Yeah, it's not correct.
That part is true that you'll have more successful collections. So that means you're going to have, but he said proportion, right? So percentage wise, you're going to have the same. So it's going to be, this one is going to be 1 and 4. Let's double check this one. Which one is this? 13, right? B. 1 and 4. I said, but this one, number 3, right? Make sure you understand this properly. That
Okay.
and let me explain number 3 as well, because I said, remember one thing that there are two things. And we did this, right? We wrote this down as well. That rate of reaction. Just a second. Where did we write this down? That wasn't this page. Yeah, this one. So I talked about frequency and effectiveness of collisions, right? What effective means is that frequency means that you had 50 collisions, now you have 100 collisions. So obviously the reaction is going to be faster, right? So let's think of it this way. Make sure you make this like you had 50 collisions. Effective means that out of those 50 collisions, 10 were effective. I mean, that meant that 10 was successful and they ended up producing the product. You understand the point that out of the 50 collisions, or we can just make it 100 collisions, right? And out of those 100 collisions, 10 of them were effective. So not all collisions will lead to a reaction. You're going to have collisions, and then out of those collisions, a few of them will eventually lead to a reaction, right?
Yes.
So if you have 100 collisions and none of them are effective, so that means there is no reaction, right? Because even though you're having collisions, but you're not having successful collisions. So 10 are effective, right? What does effective
Yes.
collisions mean? That only 10 of the particles had sufficient activation energy. Like the other collisions maybe happened too slowly. The particles, they collided, but they did not break the bonds because they were. I mean, this is what happens at lower temperature, right? That the particles are colliding, but they just don't have enough energy to break the old bonds. So unless the old bonds are broken, the reaction is not going to happen. So which is why collisions does not mean that there's going to be a reaction. Like at lower temperatures, you don't have a reaction. Why? Because well, you have a very slow reaction. Why? Because the particles will collide, but it won't lead to anything, right? So only 10 collisions have sufficient activation energy. And I'm going to call that EA. So that means that only 10 of the particles that were colliding had sufficient energy so that they had enough force to bump into each other and resulting in a reaction, right? The others had less energy. Now, what happens if I increase temperature? When I increase temperature, what happens is that now I have particles moving much faster. So I have 200 collisions. So out of 200 collisions, now 20 of them will be effective collisions. So that means 20 collisions have sufficient activation energy, right? Is that clear? So that's why you're having more reaction, because not only are your collisions increasing, but your effective collisions are also increasing. Is that clear?
Yes.
Yes.
But the proportion remains the same. Like how many are effective? 10%, right? You had 100 collisions, only 10%. Proportion means percentage, right? So out of 100 collisions, only 10% were effective. Out of 200 collisions, you have 20 effective collisions. So that means you still have the same percentage of effective collisions. Is that clear?
Yes.
So even though your number of effective collisions are increasing, no matter what you do, you increase pressure, you increase concentration, increase surface area, the number of collisions increase, and the number of effective collisions also increase. But proportionally, they're still the same. I mean, still the same percentage, right? So which is why this statement, a greater proportion, no, you're still getting the same percentage of effective, even though they are increasing, but they are still the same percentage. Is that clear?
Yes.
But when you add a catalyst, what a catalyst does is that it increases the percentage of effective collisions. So now you're supposed to have 10% effective collisions, but with the presence of a catalyst, 50 of them are now successful. So now your percentage of effective collisions, or the proportion of effective collisions, has gone up. So that is what a catalyst does. It increases the number of effective collisions, or the proportion of effective collisions. Is that clear?
Yes.
That's why, because he was talking about proportion, that's why that statement was wrong. If he had talked about instead of proportion, if instead of proportion he had just talked about that they are greater colliding molecules having the required activation, then it would have been true. Is that clear?
Yes.
Chalo. As the next one, when the colorless gas N2O4 is heated, it forms a brown gas NO2. So N2O4 is heated, it turns into. When the reaction mixture is cooled, the brown. This is colorless. Sorry, this is N2O4. And that's brown. And then it turns back to color. So it's a reversible reaction, right? And you can balance it. So when it's heated, I say it turns brown. When it's cooled, it goes back to colorless. So I mean it's a reversible. That's it. They didn't really ask you. They're not really asking you anything in detail. But is this clear? That's a reversible reaction. You clear?
Yes.
So what is added to anhydrous copper to sulfate? What happens? Do you know what the color of anhydrous copper 2 sulfate is? It's used as a test for water. Where's the data sheet? So you can remember this one is a test for water. So anhydrous copper sulfate is white. Hydrous copper sulfate with water, that's blue in color. Is that clear? So that means it turns blue. And since bonds are forming, bond formation is exothermic. It's going to be B. The reason it's going to be exothermic is that when water gets added to it, bonds are formed between the crystal and water molecules. So over here, bond formation is happening. And remember, bond formation is always exothermic. Is that clear?
Yes.
ठीक है चलो अभी अगला आंसर करो this one. So Safa Barma endothermic. Which one is endothermic?
The endothermic one. B.
Yep, that's true. Okay, and endothermic is the forward one. Yeah, that's fine. The next one is a hydrogen oxygen fuel cell. What was the concept of a hydrogen oxygen fuel cell? That you had two electrodes, and there were reactions that were happening at the two electrodes. You just have to. Okay, it's in the notes sheet here, the one that we. Where's the where's electrolysis? Fuel cell, right? Now, all you have to remember about the fuel cell is that there are two electrodes. One side is the oxygen electrode, the other side is the hydrogen electrode. What happens at the hydrogen electrode is that there's a reaction that just, I mean, you don't even have to remember the reaction. So it's just that there's a reaction, and that reaction ends up producing electrons. Hydrogen reacts with the OH ions and ends up producing electrons. So there's a lot of electrons being produced on this side. On the other side, the oxygen has a reaction and it gains electrons. So there's a loss of electrons. There's positive charge because all the electrons are gained by oxygen. So there are no more electrons left. So the electrons that are being produced on this side are going to start traveling through the external circuit and will end up on the other side. So there's going to be a current that would be flowing through the external circuit. Now, if you go back, it's given you two equations. There's electrons being produced at the hydrogen electrode and the electrons that are being gained at the oxygen electrode. And he says that the electrons that are lost at the hydrogen electrode travel through the external circuit to the oxygen electrode where they're gained by the oxygen. So this side produces electrons, the other side gains electrons. So this side electrons will travel and they will move to the other side. So a hydrogen oxygen fuel cell is operated for a period of time and 4 moles of oxygen molecules are consumed. What mass of hydrogen is consumed? So it's a moles question.
It is.
He says 4 moles of oxygen molecules are consumed.
Yeah. So
Now the first thing, remember the first thing that you're going to do. You're going to write an overall reaction. How do you write an overall equation? Like we've done this over here in the notes. The way you do it is that you add up the two equations. You've got electrons being produced at one side, you've got electrons being produced on one side, electrons being gained on the other side. You write down both reactions. Like over here, you've written down both reactions, right? And
yes.
you simply add them up. But before adding them up, the electrons gain and loss, they have to be equal. Like if this side produces 2 electrons, that side should gain 2 electrons. Okay. So the electrons that are produced and the electrons that are gained, they must be equal. So I go back to the question. There are 4 electrons being gained by the oxygen electrode. So there should be 4 electrons that are being lost at the hydrogen electrode, right? So I'm going to double everything on this side. Is that clear?
Yes.
And then I'm going to add them up. So the left side, add up the left side. So there is 2H2. What's on the left side of this side? It's all of this. Plus O2 plus 2H2O plus. So that's all my left side. Then I add up the right side. So right side is this, this, and this, right? So it's 4H plus 1
Yes.
plus 4 electrons plus the other equation on the right side is 4OH minus 1. You have 4OH minus 1, right? And then what we can do is can we simplify this? The 4 electrons. will get cancelled out. Yeah, I guess that's it. So what we just need to know is what is the ratio of oxygen and hydrogen? That's just this part. So it's 1:2, right?
Yeah.
So that means if how many moles, 4 moles of oxygen are consumed. So how many moles of hydrogen? That's going to be 8. Is that clear?
Yes.
So that's going to be. So I know that's 8 moles of H2, right? So can you figure out the mass of 8 moles of H2?
So if it's 8 mole, then we multiply it by 2, which will give us 16.
The answer is 16. Is that clear?
Yes.
So next one, the oxides of two
Yes.
elements. So the oxides of two elements X and Y are separately dissolved in water and the pH of each solution is tested. So there's oxide, there's an acidic oxide, and there's a basic oxide. So which one is metal oxide, which one is non-metal oxide?
For acid, it's gonna be
Remember, metal oxides are basic.
yeah. Wait, I know what this one is gonna be. X is oxide. Oxide is acidic, that's X. So it's either A or B. And then oxide is basic is Y, 2. And then metal is, wait,
Metal is Y.
Yeah, it cannot be
So it's the
acidic.
B.
Yeah.
That's me. Is that clear? Non-metal oxides are all acidic. Sulfur dioxide,
Yes.
nitrogen, they all form acids, right? Metal oxides, they all form bases. Sodium oxide will form NaOH, and so on. These are going to form sulfurous acid, nitric acid, etc. As an acid is neutralized by adding an excess of insoluble solid base. This is excess method. When you add an insoluble, whenever you start off with an insoluble reactant, that's excess method, right? Like if I try to make MgCl2, so you're going to add excess Mg to the acid, and you're going to keep on adding until it's in excess. And then what is the next step that you're going to do? And so what's the next step in the excess method?
After excess, you stir it? No, wait, you don't.
You keep on adding. Where's the excess method? Just like
Yeah, you keep on adding it and then you filter it out and then you will heat no wait, you'll filter it out and then comes evaporation and then crystallization.
so you filter it out. The acid will
Yeah.
get all used up because you added excess. Then you filter out the Mg. So you're just left with the salt, and you evaporate and then crystallize, right? Is that clear?
Yes. Yes.
Next one, 20. J gains electrons in a redox reaction. So which statement is correct?
It is B. It's B, Mr. Fahad.
Gains electrons is reduced. Anything that's get reduced is an oxidizing agent, right?
Yeah.
And so it's B. So this element in group 4 of the periodic table is shown. What does not occur in group 4 is it is descended.
Is it is what does not? Oh, C.
Yeah. They all have the same number of valence shell. It's group 4, so
Yeah.
4 electrons in the outer shell. So that does not change. You get more shells, that's true. They become more metallic because tin is a metal, lead is a metal, while carbon is a non-metal, right? So, and these two are metalloids. So in group 4, what happens is, again, periodic table. Group 4, what happens is, remember there's a staircase that divides the metal and the non-metal. So it goes right right through the center of group 4. Carbon is a non-metal, while the bottom one, lead and tin, are metals taken.
Yes.
So which statement or acids are correct? What's the definition of an acid?
Acid is a proton acceptor.
It's a proton donor.
Oh, donor. Whoops.
It produces, it gives off H plus one ions, right?
Yeah. So A is wrong,
This is also wrong.
and so is B, and so is C. So it's no wait.
I mean, this is true because
D, yeah, it's D.
this
C
is a
is
weak
wrong.
acid, right?
Yes.
So which elements have both a high melting point and variable oxidation states? But who has variable oxidation states and very high melting points? And there are 3 more properties that forms colored compounds, they've got high densities, and they're very good catalysts,
These ones are transition elements.
transition elements, right? So there are 5 properties.
Yes.
24, lithium, sodium, potassium, they're all in group 1. Chlorine, bromine, iodine are in group 7. Which two identifies the least dense of these elements? Lithium, sodium, potassium. On the other side, you got what? Chlorine, bromine, iodine. What is chlorine? What is the state of chlorine?
Chlorine is a gas, so it's the least dense. So it's A or C. And then you have in group 1, it's gonna be the least like with the nucleon one, the mass.
What
So it's
happens?
gonna be lithium. So it's A.
It's going to be A. Let's double check this. 24, right?
Yes.
A. Then you've got PQ and R metals, right? So which one is, I mean, this is easy. Which one is the least reactive? They've given you a bunch of reactions. R of PQ, R and S, which one is the least reactive? Which one is the most reactive?
It is T is the least reactive because it has no reaction and then it's reduced. And then after that it is S because it's very slow, and then Q, and then R.
Yeah. So that's pretty obvious. Everything is given over here. Now, 26, the number of protons and the number of neutrons in the atom of X, Y, and Z are shown. So which statement about these elements is correct? And remember, these are atoms. X and Y are isotopes. Is that true? The first one, is that true?
No.
It's not true because they're supposed to have the same protons but different neutrons.
Yeah.
Z forms an ion with a +2 charge.
No.
Which group is Z in?
C is in group
Wait, it's
8.
eight
No,
protons.
wait.
Eight. I mean, you can just have a look at the periodic table. 8 protons, right? That's oxygen, right?
Yeah.
What charge will it have?
It will have -2.
-2, right? So that's wrong because not +2. It's going to be -2.
Yeah.
X and Y Z react together to form an ionic compound.
No.
X and Z. Which group is X in?
X is in group
6 protons.
4.
So
Group
that's a
4.
non-metal. This is also a non-metal. So they're going to form a covalent compound, right? X
Yeah. So D
carbon.
then.
It's probably going to form carbon dioxide because carbon and oxygen, right? So that's also not true. They're all non-metals. That's true. This is group 4. This is 7 is this is nitrogen. This is carbon. This is nitrogen. This is oxygen, right? And remember,
Yes.
elements are identified by the protons. So which one is an alloy?
It is
D.
Yeah. Different sized atoms because and what are the alloys? Bronze is what copper and tin. Brass is copper and zinc. Then you've got steel, which is iron and carbon. It's a mixture of a metal and some impurity. You got a haphazard structure. The atoms are not able to slip and slide that easily, which is why it's stronger, less malleable, and less ductile. 3 compounds J and L are heated in a Bunsen burner. Results are shown. Who relights a glowing splint? What test is this?
it is for this one it is
I mean,
yes.
what is the gas produced?
Oxygen.
Oxygen gas, right?
Yeah.
So decomposition of a carbonate or a nitrate, who produces oxygen?
Nitrate.
Yeah, nitrate will produce oxygen, right? Colorless gas, who does?
And that carbon dioxide turns lime water milky.
So that's a carbonate, right?
Yeah.
And the last one, no reaction. So I guess it's going to
That's
be
magnesium carbonate.
C because remember we learned that when it comes to
Right.
decomposition, the unreactive decompose very easily. I mean, their compounds decompose easily. So I guess it's yeah, that's the only option. If the first one is definitely nitrate, right? So you can't bring in carbonate, so that's definitely wrong. Then between these two, it could be potassium carbonate, it could be magnesium carbonate, but magnesium carbonate is the unreactive one, so that will decompose. While the last one, potassium, is very reactive, so its carbonate would probably not decompose. Is that clear?
Yeah.
Potassium is group 1, so very reactive compounds of very reactive elements, they don't decompose that easily. So, okay, let's continue tomorrow then, okay?
Okay, Allah Hafiz.
Okay.